It's 11. Good morning, everyone. I would like to thank everybody who is attending with us this, I will say, very important webinar. It's organized under the umbrella of GCC SIGRE in collaboration with GCC Lab, the first high voltage high power lab in the area. And we have with us Siemens Energy today. Today, our webinar cover a very important subject titled Power Transformers as a Potential Bottlenecks for Grid Expansion. As all of you know, that power transformers are critical components for electrical power system responsible for stepping up and down voltages level to ensure the efficient transmission and distribution of electricity. As a global demand for electricity continues to grow, and as a nations pursue ambitious grid modernization and renewable integration goals, the ability to expand and upgrade transmission infrastructure becomes increasingly vital. However, power transformers are emerging as significant potential bottlenecks in this process. This bottleneck arises from several key factors, namely the long lead times for manufacturing and the delivery, complex procurement and installation processes, limited manufacturing capacity worldwide, and aging infrastructure that requires, as you may know, requires replacement or reinforcement. Additionally, the increasing complexity of the grid networks, coupled with the higher reliability and efficiency expansions, put further strains on transformers availability and performance. Without adequate planning and investment in the transformers capacity and supply chain resilience, grid expansions project risks delays, increased costs, and compromised reliability. And understanding and addressing the roles of power transformers in grid expansion is essential for energy planners, utilities, and policymakers to achieve energy security and the sustainability goals. Today with us this morning, Mr. Thomas Kessler, I hope I pronounce your name correct. He is the technical sales expert from Siemens Energy, and he has a very wide range of experience throughout Siemens. He will be with us this morning talking about this very important subject. Mr. Thomas, the floor is yours. You have from 30 to 45 minutes. Then we will be having 15 minutes for Q&A. I would like to highlight that your mic is not your mic and your cam is not functioning. So if you have questions, please write it on a chat, and I will be more than happy to translate this to Mr. Thomas. Mr. Thomas, please.
Yes, thank you so much, dear colleagues, Mr. Mohammed, and dear colleagues. And welcome also from my side. I'm located in Nuremberg in Germany today. And yes, I will talk about the power transformers as potential bottlenecks for grid expansion and what is behind that. I will explain to you, let me say, some analytics that I have done about the background, about the reasons. And that is the first chapter. The second chapter of this meeting, of this webinar, is then what can we do to, what can we do to master the situation, to improve the situation, and to avoid bottlenecks. And that followed in chapter 3, then concrete, let me say, proposals that we can jointly undertake to improve the situation. And then last but not least, I will make a brief summary. Okay, but let me start a little bit with about the background of the long delivery times. And the long transformer delivery times, they are a major challenge for end users in the Middle East, Europe, and America. And maybe what you notice is that some regions are missing in the headline. And one of the regions that are missing, I refer to in the next slide. So, but starting with the transformer delivery time as major challenge in Europe and in Middle East, Europe and North America, there we have delivery times of 3 to 5 years. And our customers there, together with us, we are thinking about going new ways instead of focusing on the purchase of new units. But the question is, why are the delivery times this long? In China, and that is one of the countries, one of the regions missing in the headline, the situation is different. If you talk to Chinese end users, like I have done, then they think the delivery times are quite acceptable for them, because for new transformers it is only 1 year. And if you ask them what is their major challenge, then it is the increase of the short circuit capacity and the transmission capacity of power transformers for substations. So a significant difference between customer perceptions in different regions of the world. The reasons for the huge demand for new transformers, of course, is quite obvious. It is, like you can see on the picture on the left, it is everything about renewables. It is about electrification, like e-cars, but also e-trains and stuff like this. It is renewable integration. It is also the electrification of industrial processes, like, for example, replacement of gas-fired heating by electrical heating in the steel industry. So this is the, let me say, the growth factor or the grid development factor, but this impact or this effect is accompanied by another effect. And this effect is the installed base aging. In a transformer, we have got, besides high voltage, we have got biomass like paper, like wood, like oil. And especially in your region, the transformers are exposed to high temperatures, to sand, to storms and sun. So we have got a significant aging impact. And this impact can then, over time, increase the risk of failure. So if we want to have a resilient and reliable grid, and which is increasing, which is developing, then we have to consider all aspects, like the renewables, like the electrification, and the aging of the installed base. And this is let me say, a picture, a qualitative picture. And in the next step, then I'm going to translate that, let me say, into quantifiable information. The question is, what does a transformer delivery time of 4 years mean for you as end users and also as our customers and partners? It means, by rule of thumb, that only roughly about 25% of the demand per annum, per year, is covered by the supply of new units. As I mentioned, so what is how is the demand for new transformer created? It is created in this ranking: grid expansion, the growth factor, the compensation of retirements, and retirement rate is about 1% globally, or has been used to be 1%. And of course, it is the replacement of failed units. So all three factors, they are responsible for the demand for new transformers. And if only 25% of this demand is covered presently by the supply of new transformers, then it is obvious that we have got a delta. And the question, and I try to give an answer to you during this webinar, is how to manage the situation, how to manage the delta. And this delta is a potential, which I explain to you also later on, for the modernization and uprating of installed base transformers. It needs to be said is, I'm only considering the need for transformers in the present and in this year, in the next year. What is the baseline is, and what needs to be said and emphasized, that all these considerations is nothing without keeping the installed base alive, without keeping the installed base happy. And if we do not take care about the installed base, then this means in practice the delta will be increased. And so that is an important message, that I will not only consider the modernization, uprating or repairs, also consider maintenance, because to manage this situation, this critical supply chain situation, we need to define a holistic approach. So let's have a look in the situation in Western Europe and in Middle East. So the diagram is the same. The delta I have marked in red, and the question is, why did I mark it in red? In the Middle East and Western Europe, our experience is that the customers, end users, they focus on the purchase of new assets. And then, in combination with the strong growth of the grids, with the growth of the economies, with the electrification, this results in long delivery times for new transformers. And the delivery times, they will increase continuously, but as I said, the installed base is aging. In future, this might result in shock wave effects. Shockwave effects because of delayed investments, and maybe also shockwave effects because of installed base transformer failing due to aging, for example. So that is let me say, the analytics and the interpretation for Middle East, and also for my region, for Western Europe, and also in Germany. Let's have a look to China. In China, the situation is different. The diagram, of course, is the same. But in China, we see as OEMs substantial transformer modernization orders in our books. It is the same with Siemens Energy, but also the same with Hitachi Energy, and also with Chinese suppliers. And there, the modernization business is an essential part of our OEM business in the country. So we consider, for us, it does not make a difference if to sell a new transformer or if to sell a modernized, refurbished or repaired transformers. And because of this more holistic perspective, the result is that the delivery times for new transformers are comparably fast, much faster than in Europe. And later on, I try to explain to you why the situation is like that. Where is a difference? But we also have a good practice there, and the question is, what can we learn? And I change now from the commercial and from the strategic to the regulatory focus, because the regulation plays a key factor. And maybe we have also got a somebody with us working in the area of regulation. I took two examples from the United States and from Saudi Arabia, which I found in the internet. And in both examples, and the situation is in Europe the very same, there is an ROI, return on investment, on CapEx, and productivity pressure on OpEx. And this means that especially the transmission companies, because they are the regulated customers, they are more interested in the purchase of new assets because they get a return on investment for that. And on OpEx and the modernization of transformers and the repair of transformers often are under productivity pressure. So there are no budgets available. And then in Saudi Arabia, at least according to my analysis and my interpretation, there is a position extraordinary OpEx. And this means extraordinary OpEx that in case of unexpected failures, these positions can be pulled through to the end user. So there is no real productivity pressure on that. And in China, this consideration looks totally different. I cannot show you the Chinese formula, but in China, there is a balanced consideration of CapEx and OpEx spendings. So the Chinese regulator, for example, has got sustainability targets, process sustainability targets on the utilities, and has somehow equal consideration of CapEx and OpEx. So the perspective of the Chinese government and the Chinese regulator is very output oriented and very holistic. And that is, from my point of view, the background why modernization is in China an attractive business case for the end users as well as the transformer supplying OEMs. So the question arises, I told you a little bit about the background of long delivery times and my interpretation. And the interpretation and background then defines the starting point, what can be done to manage the situation. So the technical approaches, increasing the lifetime and decelerating the aging. And what does it mean? I tried to explain to you by diagrams or pictures that I have taken from the technical brochure 255. And this is about life extension and of oil-filled transformers. And so this is the original picture I took. So, and scheduled according to this brochure, the transformer lifetime is about 50 years in average. And now, what is the target? What is the target? The target is now, of course, to extend this lifetime. So to extend this lifetime, and the impact of the lifetime extension then is a reduced need for new transformers. And that is what I tried to, I separated the diagram. So the idea is increasing the lifetime and decelerating the aging. So that is the strategic starting point and approach. And this is then later on done or executed by preventive maintenance or modernization of transformers. The next step is also increasing the lifetime of an aged transformer, I should say, by improving the transformer conditions. So if a transformer has already reached, let me say, the last third of the bathtub curve, then by certain defined transformer service actions, service measures, we can improve the transformer conditions. We can rejuvenate the transformer And then to a certain degree, also in this case, we can stretch the bathtub curve and expand the transformer lifetime. And then there is another topic which is related to the transformer conditions. The question is, that was a theory, but what does it mean in practice? What is a physical and chemical starting point to reduce the aging rate of a transformer, or maybe also to increase the transmission capacity? And this is described, well described in the IST standard 60076. And this is the loading guide for oil immersed power transformers. And there is a table showing the relative aging rates due to hotspot temperature, which looks very statistically, but there is a clear message behind it. If you reduce the hotspot temperature by 6 degrees Celsius or 6 Kelvin, it is from 116 to 110 or 110 to 104. You can decrease the aging rate of the paper insulation by 50%. Or alternatively, you can increase the power, the MVA rating of the transformer accordingly. So this is decreasing the aging rate. That is the physical background behind the lifetime extension and rejuvenalization of installed base transformers. And then also for the regulators, I can make a proposal. We should consider increasingly a TOTEX, which stands for total expenditures and output-based regulation of transmission companies, like this example from the UK, where we also do not have really this long delivery time topic. In the UK, we have got a regulatory regime called Ofgem and RIO2, RIIO, innovation, its incentives, regulation, innovation, incentives, and output. And this is strictly based on incentives to accomplish certain KPIs, which are defined by the regulator. And on innovation, there are incentives on innovation, like, for example, digitalization or sustainability. And there are incentives on outputs. There are for the achievement of certain KPIs, like, for example, renewable integration, like increasing the number of grid connections, like availability of the transmission grids, and similar. So, having said this, we have talked about the background of the long delivery times. We have talked about what we can do to manage the situation. And now it's time to show the way forward, a holistic approach. And I need to emphasize it. We really need to think about a holistic approach, and we must not think in silos if we want to manage this situation successfully. So the way forward, as we see it, is more strategic partnerships between OEMs and end users for transformer fleet management. And why is a strategic partnership so important? Because the maintenance and the modernization of transformers requires similar or the same resources like the manufacturing of new transformers. And the perfect showcase for us as Siemens Energy is how it works in China, where the factory staff also works in this very often in the field of services, and vice versa, because we simply need the same equipment, we need the same knowledge. And the target of this strategic partnership, of course, is efficient and high quality solutions for you as end users and for us that we have a continuous workload for the vendors, or the same with Siemens Energy if Hitachi. So that is a win-win situation described by these targets. And the benefits that you have is a long-term survival and the availability of the installed base, and keeping the installed base alive, available, and happy. That is one pillar of the grid expansion, and it reduces the dependency on the supplies of new transformers. And the way forward is managing the transformer life cycle in accordance with the ISO 55000. And the ISO 55000 is an international asset management standard coming from the UK, then traveled to East Asia, especially Hong Kong, and now an increasing number of countries is applying the ISO 55000 as backbone for their asset management. And in this standard, so there are some typical service actions occurring over the transformer lifetime, like expert hotline, preventive maintenance, the replacement of bushing, recycling or replacement of transformers, and the repair or refurbishment of transformers. So, starting, what can we do? I told you at the beginning, having a look at the stretch of the bathtub curve. First, what can we do to maintain the transformer conditions? And the aging mainly is taking place in the tank, and that is why the regeneration and the drying of the insulating oil is important if it is indicated by oil diagnostics. So on this picture, so what does this proposal contain? It covers oil diagnostics like oil sampling, and by the color of the oil sample, you can already recognize under which conditions most likely the oil is. And the color represents roughly the aging of the transformer oil. And then the transformer oil in the second step can either be regenerated. So that is when we take aggressive chemicals out of the oil, and which affects and which attacks, for example, the paper of the winding, or we take the moisture out from the oil, or we extract it from the oil by applying oil drying. What needs to be said is that both processes, the transformer oil regeneration and the transformer oil drying, they can be executed or applied to the energized transformer. So there is no need to shut down the transformer. And the benefit of this exercise is that after regeneration and after drying, the transformer oil is in as good as new or better conditions of the insulating oil. And also, the carbon footprint is significantly reduced in comparison with the exchange of oil. Very important for you, because we are talking, the background is bottlenecks and delivery times. The delay time for this topic is about 6 months per transformer. It depends on the type and number of transformers you want to regenerate, and of course also on the availability of the equipment. But of course it is much less than 3 or 4 years. The next thing is working out strategic spare part concepts, and these spare parts concepts, they enable the fast availability of spares when they are required. Because why is this topic spares part is also mission critical? It's mission critical because some spare parts, especially like bushings and the tap changer, they have got delay times, delivery times. In the meanwhile, they are much more than 12 months sometimes. They're also now somewhere going into the direction of 1.5 or 2 years. So it is important in the sense of availability of spares and in the sense of availability of transformers. It is also important to take care about the strategic spares. So the benefit, and here we are with the benefit. The benefit is the off-the-shelf availability of spares after building up spare parts stock. And this requires, this service requires a delay time somewhere between 6 months and 1 year for building up, for defining and building up the strategic spare parts stock. Then one very important topic is the modernization of transformers, the preventive exchange of bushings at the age of 25 to 30 years. Because in some secret papers or reports like the 642 and also the AS887, which is the Transformer Economics report, the lifetime of bushings mostly is not this long like the lifetime of a transformer. And the maximum lifetime of bushing design is somewhere in the range of 25 years. And this is depending, of course, on the bushing technology. And with an increasing age, there is a risk of incidents increasing, of incidents caused by the failure of bushings. And I have been involved in the last year into 4 failures of transformers that have been caused by bushings. Mostly these failures occurred in power plants, and all of them, they have been, frankly, the end users did not really took not care about the bushings. And so this is a critical topic. And just for your information, I read yesterday an article in a newspaper that some airlines, they put National Grid of UK in a law case because they think that the failure of the substation supplying energy to the Heathrow Airport, that the background has been poor maintenance of a transformer and a transformer bushing. And so that was the root cause of this disaster. And so I really need to emphasize that preventive exchange of bushings, or at least inspection of bushings, is very important for the availability and lifetime extension of assets. And of course, the benefit is obvious. The benefit is after that, the bushings are in as good as new conditions. And the delay time, if you have a bushing on stock, and if you have carefully planned the exchange of bushing, the delay time is 1 week. And this, of course, is then most likely you do not need to remove the transformer and install a spare unit. You can do this exercise on site if it is carefully planned and if the bushings are on stock. And this is why the strategic spare part concept is this important. Then, with regards, I said it also in the previous slides about the importance of the hotspot temperature inside the tank and its impact on the transformer capacity and the transformer aging. So one important or attractive measure to increase the transformer is increasing the transformer cooling capacity. And the benefit for you as end users of the increase of the cooling capacity is either that you get on the fast track an increase of the transmission capacity by about 10%, and that of course depends on the transformer design. Alternatively, the relative aging of the isolation may be decelerated by approximately 50% or maybe more. And the delay time for this is 6 months or less. And so this is why I say here you can really increase the transmission capacity on the fast track. Next step is repair of failed or refurbishment of aged transformer. You remember the bathtub curve at the last third, and this one is now, of course, improving significantly the transformer conditions. Either, for example, by the replacement of a failed winding or of failed windings, or by a general upgrade of the transformers, including the piping, rust protection, and auxiliaries. So the benefit is also in this case, significant improvement of the transformer conditions, and based on that, an increased lifetime extension of the asset. And the delay time for a transformer repair or refurbishment gets from some months to 1 year. It depends on the scope and of course on the planning. So if we do this in a, let me say, in a planned manner, in a preventive manner, then of course we can provide or we can offer much faster delivery times than in case of an unplanned outage. And of course, a planned modernization, planned repair always is much cheaper or much more, much cheaper than an unplanned one. For the installed base transformers, we have also got some customer references. I took some from South America, and where we exchanged complete windings and or where we upgraded the transformer, or where we increased, like on the right-hand side, where we increased the cooling capacities. Some of these exercises we have done in a workshop, and some of the exercises we have done on site. So, getting closer to the end. So the proposal, the final proposal as a summary is holistic transformer fleet management, referring to the needs, to your needs, conditions, relevance, and time. So this holistic approach as part of a strategic partnership, that is our approach how to manage the situation. I tried to put it of long delivery times. I have tried to put it into a diagram. On the vertical, on the horizontal axis, we have got the importance and the relevance of the asset. And on the vertical axis, we have got the conditions of the assets. And of course, at the top right, you have got the most critical ones. And because of conditions and because of importance, and because these are so critical, and we have got the delivery time challenge. So what you should seriously consider is, instead of planning a replacement, to have these units repaired as fast as possible, and to schedule the replacement for units which are critical but not this critical, where time is not this important. And for the other ones, applying standard operation and maintenance, or lifetime extending measures. So this would be a holistic approach with regards to maintaining the installed base, or considering the uprating of transformers to gain additional grid capacity on the fast track. And the time frame for this exercise is about 1 year, and the benefit is a well-balanced, hopefully CapEx OpEx budgets in accordance with grid development plans and the avoidance of pent-up investments and shockwave effects. And the proposal for the regulators is an output-based regulation of transmission companies, like, for example, the RIIO from the United Kingdom. And here that has to be defined by the regulator, of course, according to the national priorities, like in this case, the safety, the reliability, environmental impact, customer and stakeholder satisfaction, and customer connections. And the benefit is, because of the focus on the outputs, there is an equal treatment of CapEx and OpEx, and there is more flexibility to manage the transformer delivery time topic. And that brings me to the summary. And summary is fleet management programs and strategic partnerships between OEMs and end users. This is or in this case, my recommendation to master the delivery time topics. The aging of the installed base is the biggest challenge, the biggest risk, because it may result in increasing number of failures or shockwave effects. The proposal is these fleet management programs and partnerships between end users and OEMs. And for the regulators, focus on the purpose of the grid, and the purpose of the grid is providing the intended output. And in any case, anyway, the well-balanced CapEx OpEx budgets and the avoidance of shockwave effects is the main technical and financial benefit for end users. So, lastly, I want to thank you for joining this webinar. And by avoiding air travel, we have saved minimum 2,400 kilograms of CO2 emissions for me traveling to your region. And so that is a big benefit of webinars, and I would appreciate that we can have some more webinars. However, personal contacts are very important, and this is why I hope to see you soon again in person on the GCC Power 2025. And I will in Kuwait, where I will have a presentation or paper about transformer failures and the root causes and the repair of power transformers. And having said that, I hand over again to Mr. Mohammed and for the Q&A.
Thank you so much. Thank you so much, Mr. Thomas, for this exciting presentation. Actually, myself, I learned a lot. It is very important information since nowadays in this region, we know that the lead time of having a new unit is becoming a nightmare for everyone. I have a couple of questions. I will be just mentioning the related one. The rest I can send it to you by email. You can answer them at your spare time. One of the question is one of our colleagues attending this webinar. He said there is confusion, at least for him, between the lifetime and aging. Would you please elaborate more? What's the difference when you're talking about the lifetime of transformers and the aging?
The lifetime of the transformer is, for example, 50 years. That is the expected. The lifetime is, how should I say? The lifetime is an expectation. It can be an expectation, or it can also be a status. And the aging is a process that has an impact on the lifetime. So the aging is a process taking place, and the lifetime is a result of this process, of the aging process. But not only the aging process, but also of the engineering process. The engineering and the aging, and that defines the lifetime. I hope I explained it in a, let me say, understandable manner. It's a good question. I try to explain it in the best way.
Let's say the lifetime is the theoretical life that the transformer is supposed to live. The aging is the processes on the way. Sometimes you will not be able to achieve the
Perfect
theoretical lifetime, but through the process. It depends on the process, whether you reach that specific date or you may reach it earlier.
Perfect explanation. Thank you so much.
Okay, I have the second question from Mr. Zahid Ali. What are the new approaches to increase the cooling capacity?
To increase the cooling capacity, of course, it depends on the cooling scheme of the transformer. So in the easiest way, it is bigger radiators, or it is about increasing number of fans. And that is for the installed base transformers. And for new transformers, that because of the continuous improvement of transformers, of course, there are new conducting or better conducting materials, and the improved conducting materials then, of course, cause less heat losses, and then also decelerate the aging of transformers. So you have to separate between installed base and between new transformers.
Okay. I have another question from Mr. Hamdi Al-Haj. What are the latest artificial intelligence, AI technologies for enhancing the operation efficiency, reliability, and failure rate reduction of transformers?
This is a challenging topic. So, but I try to explain. We have in our online monitoring systems, like the Sensformer, we have to a certain degree AI implemented. We have AI implemented, for example, to identify evolving failures and to identify evolving failures and to compute recommendation for improving or corrective action. That is where we have AI implemented. And the advantage of a monitoring system is that it is continuously fed with data like the DGA concentration inside the transformer, or like the capacity of the bushings as indicators for the conditional status of the asset. With regards to the failure, from my point of view, I have discussed this just yesterday with an expert. So there is a big challenge for AI on transformers if the transformers do not have monitoring on board. There is no continuous flow of data from transformers to AI. So AI requires training. So all these, let me say, tools like ChatGPT, for example, or Copilot, they are continuously fed by millions of data. And there are thousands of IT workers, for example, in Nairobi area in Kenya, doing nothing else than providing data or feeding data into AI. And in the transformer world, we do not have these mass data that are usually required to train AI. So at the moment, And I think that will be also the case in the next years. At the moment, AI is, from my point, is especially applied in online monitoring and transformer online monitoring. And but for condition assessments or for the evaluation of transformer failures, at the moment, I do not see really a significant impact of AI over the next years because there is a huge, for us, it is a huge risk, but the number of data is, or the flow of data, that is a critical factor. And that is what we do not have this far. And having a look, I referred in my speech to the report 642, which is the Transformer Reliability Survey. There are maybe 1,000, I think population of 1,000 transformers is evaluated, and the number of failures then is somewhere in the range of 40 or 50. And for AI training, this amount of data is nothing. For us, it is an important information in the utility and in the transmission world, but for the AI world, this is a very small amount of data.
Okay. I have a question in here regarding the use of mineral oil versus the ester oil and how this will impact or affect the life cycle.
Yeah, the lifetime of all the same what kind of oil you're using. The topic is applying the proper maintenance. The processes that I have described here can also be applied to ester oils. And I would assume that the lifetime of ester oils is longer than for mineral oils, but nevertheless, the question always is the proper maintenance and the proper asset management of the transformer.
Okay. Second question is, what are the best practices for planning transformer capacity in the areas with rapidly growing loads?
If I would say what is the best practice, then best practice is, from my point of view, always China Light and Power in Hong Kong. Because what I know is they monitor each and everything on transformers and on circuit breakers, for example. And they continuously improve the most important KPIs, like the number of connections on the one hand, and the reduction of the transmission fees, the transmission rates on the other hand. So I think China Light and Power it's worth to have a look into their processes.
Okay, I have the last question is
and then what I need to say is in China we have got a number of customers, and they continuously, that are especially some of the China state companies, their provincial bureaus, they also continuously upgrade their transformers together with us.
The last question from Mr. Amr Al-Anizi. Is it advisable to specify high temperature insulation systems for the transformer insulation system to enhance their expected service life and provide additional lead time?
What do you mean by additional lead time or delivery time?
He means delivery time.
It depends, of course, on the application. Is the transformer inside? Is it outside? and what is the impact? And in general, of course, it makes sense.
But how about versus, I mean, cost?
That, that finally, it is finally, you're totally right. Finally, it is a risk evaluation. You have to have, on the one hand, you have the additional costs. On the other hand, and additional costs and additional delivery times. On the other hand, you have got a more robust transformer. So, having said that, the investment is higher and the failure rate is lower. And then you have to calculate what is the risk in case of failure. And then there is a delta of additional cost and reduced risk exposure per year. And if you then summarize in this by discounted cash flow over lifetime, then you can see what is more, what is less beneficial. So that is my answer. You have to consider this, and I'm 2 years ago I made a presentation on Sigre Gulf about transformer maintenance strategies, and to define a proper maintenance strategy, then the risk impact and the risk reduction, that is in balance with the additional costs or the required investment, that are the deciding factors. So I do not want to answer yes or no. So technically, of course, it makes sense, and but financially, you have to do a holistic consideration.
Okay, this question is from myself. You just mentioned at the beginning of the webinar that the life cycle, the life expectancy of a power transformer in Europe 50. While I will say the average life cycle here in the Gulf will not exceed 30. I mean, if a transformer exceed 30, then this is a real achievement. Most of our units in here, when they reach 30, it's like a bomb in the substation. You can expect the failures of these any time. What's the difference in practice in preventive maintenance that European utility are doing other than the GCC power utility is doing? Everybody is doing preventive maintenance, corrective maintenance, online monitoring, etc. But still the life expectancy or the average age in the Gulf is less than the average age in Europe. If we consider the heat in the Gulf, in Europe you have a very cold season, so it's the other way around. Can you elaborate on this?
Yeah, I can. I try to elaborate the best. So first of all, in Europe, so we have there is a rule. It is a state law that you have to undertake regular oil analysis and inspections on transformer. I think the law is in Germany every 2 years. So that is number one. And then number two is because of availability targets and also because of painful experiences, the customers they undertake preventive maintenance. Like for example, sometimes they have got programs like a bushing exchange and so on. So they undertake, for example, bushing exchange after 30 years if indicated by the if indicated by the conditions. Then they manage. They have asset management software in place, and they have a clearly described asset management process. And and uh, 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 and then they have also got penalties on the unavailability of assets. And the unavailable, because of another reason, the failure of a transformer is very dangerous, very expensive for a German transmission company. Because if a transformer fails, a transmission company has to undertake switching operation, because mostly another power plant has to be started to compensate the transmission capacity and to transfer it to another part of the grid. And these financial impacts, these additional costs, we call redispatch. And overall, in Germany, redispatching costs are 2 billion euros per year for the German transmission companies. And of course, they want to reduce these losses. And with regards to your region, of course, the weather extremes, they are much more severe than in my country. But the experiences I made is that you drive. We have had some failures in your region, and these failures, they have been caused because of, let me say, missing. At least we have seen in the documentation, for example, not seen preventive measures like the preventive exchange of bushings. Or also, for example, we have in one case noticed that the tap changers, the OLTC maintenance, has not been executed in accordance with the standards of the manufacturer. And it needs to be said, it's last but finally, it always comes out to a commercial, to a financial and technical consideration.
Okay, last question. So we are almost on time. How European power utility manage their purchases order? Are they buying the transformer case by case, or are they signing a long-term contract with the OEM or purchasing, let's say, capacity contract, and how they manage this to make sure the availability of the transformers whenever they need.
So they pay the utilities. If I define transmission companies as the utilities, then at least in Europe, they increasingly order larger lots of transformers. They do not order only one or two, but they order 10 or 20 and put some of them on stock, which then, of course, has a negative impact or delaying impact on the delivery times, for example, for industrial customers or for power plant customers. And this is one topic. And the other topic is because they have also got CapEx restrictions. And the other thing is they pay a fee for the reservation of slots. So they pay a fee for the reservation of slots in our factories, or the same with Hitachi. And to get a transformer, if they order now to get a transformer, for example, in the year 26 or 27, and they do not want to accept delays, then they pay a fee of 10 to 20% for a defined and guaranteed slot.
Okay, thank you so much, Mr. Thomas, for this excellent webinar. Great information, I think. Mohammed Wasil, I don't know if you are with us.
Yes, thank you also so much, dear colleagues. It was a pleasure.
Thank you. Thank you so much. Mohammed Wasil, I will leave the floor for you if you would like to announce new events or the event that will take place this year in Kuwait.
Yeah, sure. Let me share the screen with you. First of all, we need to thank all the starting Mr. Thomas and all those who attend this webinar, and this will be our start to for the webinar activities for this year. During this July, we'll have another more 2 webinars be announced and send it to you all. And we need also to just share this invitation to join us at our upcoming GCC Power in Kuwait during November.
Mohammed, I don't know if you are trying to show
Yeah,
anything.
no, just a second.
Okay.
If you can see my screen.
No, we cannot.
You can see it?
No.
I can share it.
Okay, if you would like me, I can at least give an announcement about the conference, the GCC Sigray conference.
Yes, please.
That will take place in Kuwait during the period from 10th to 12th of November. There will be several topics that will be discussed. The event will take place in Regency Hotel in Kuwait this coming November. I think this is what you want to say?
Yeah. Thank you.
Okay. So thank you all so much for being with us today, and I hope to see you to participate in our, I will say, upcoming event. We will keep you posted. Mr. Mohammed Al Wasila, he will be sending you by email about all the coming webinar. I think next week we will be having one. So having said that, thank you so much and see you soon. Bye.
Thank you.
Thank you.
Bye-bye.
Bye-bye.
Thank you all. Thank you.
قاعدين الناس.